The forecast app development is nearing the end. In the last 13 parts, we've gone from nothing to a functioning MVVM app which fetches data from an API. The only thing missing now is the detail of the future weather. This detail will show up whenever a user taps a list item on the 7 days forecast tab in our application. Hello, welcome to Coder. So in this part of this tutorial series, we are going to go from this, that whenever we tap on an item in the forecast tab, we get only a toast which says clicked. And by the end of this tutorial, we're gonna have something like this, that when we click on a list item in the detail tab, we're going to be shown the detail of the future weather. The first step which we need to take is to create the data classes, which are going to represent the unit-specific detail future weather entries. So let's go to app, the Java, first package, then data, database, and unit localized. Here we have current, we are not going to touch that, but we have also the future unit localized data classes. Over here we want to create two sub-packages, detail and list. As always, you can also get the code from this tutorial by clicking on the link in the video description, which is going to take you to resocoder.com. So now, as we have these two sub-packages, whatever we already had in the future package, so imperial simple future weather entries and all of the simple unit-specific future weather entries, we want to move it over to the list sub-package. So refactor. Once that's done, we now want to create unit-specific detail future weather entry interface under the detail sub-package. First, however, let's take a look at the unit-specific simple future weather entry, which we already have. This one has only a date, average temperature, condition text, and condition icon URL. That's because whenever we are displaying this weather only in the list of the future weather, there is not really a lot of space for the data. That's why we are only getting these 4 things from the database. However, as soon as we get to the detail of the future weather, there is much more screen real estate to display this data in. And that's why the unit-specific detail future weather entry, which we are going to create now, is going to have many more properties. So without any further ado, let's create one interface right now. It's going to be called unit-specific detail future weather entry, and it's going to have all of these properties. Date, max temperature, min temperature, average temperature, then condition text, condition icon URL, max wind speed, total precipitation, average visibility, distance, and finally the UV index. But this is only an interface. In order to actually fetch this data from the database table, we need to create some real data classes which are going to only implement this interface. So let's do that right now. We're going to have imperial detail future weather entry first. So it's going to look like this. It's a data class which implements unit-specific detail future weather entry interface, and it has all of the properties of this interface, plus it also specifies column info for every single property that there is, because for example, max temperature is not called max temperature in the database, but it's rather called max temp f. That's because if you remember, when we take a look at the entity and we go to the day, here are the names, so max temp f, max temp c, so we need to somehow convert these really unmeaningful names to something meaningful for us, because max temp c it's not even camel case correctly, so we want to camel case it and give it some nicer names, so that's why we have a different name here, but we need to account for that. That's why we have the column info. Also, column info just means whatever the name is inside the database. Then similarly to the imperial detail future weather entry, we also want to have metric detail future weather entry here. This one's gonna look pretty much the same as the imperial detail future weather entry. It's only going to have different names. So instead of max temperature F, we are fetching max temperature in degrees Celsius. Alright, once we have that, we can go to future weather data access object. And we want to add 2 functions which are gonna be for getting detailed weather by date, metric and imperial. So here they are. and they are really similar to get simple weather forecast metric and imperial, only that we are not fetching a list of these entries, but we are fetching only a single entry for a precise date. So we aren't getting where date is greater or equal, but we are getting only where date is equal. And because when we take a look at future weather entry in the entity package, we can see that the date column is unique. That means that there is a guarantee so that only a single entry can have a particular date in the database table. And because of that, we can fetch everything, so this asterisk here, so we can select everything from future weather where date is equal to the date which we are trying to fetch, because it is guaranteed that there is going to be only one future weather entry with the particular date. Alright, now we can go to the repository and we can add a function which is gonna get future weather by date. It gets passed a date and also whether or not it is metric, and we just return live data of unit specific detail future weather entry. Now we can go to the forecast repository implementation and implement all of the functions regarding this interface function. We can immediately see that we are getting an error, and that's because we are not overriding an interface function. So let's do that right now. Right under get future weather list, we're going to add an overridden function get future weather by date, and over here we again want to return with context. We're gonna run it again on the IO dispatcher, and just to be safe we wanna init weather data even from here, although it's really not necessary because whenever we get to call this function, the get future weather list function has already been called for sure, so the weather data must be initialized already, but just to be safe we are going to call it even here. It's not going to kill us or anything. And then we are going to simply return the weather data. So return add with context, and if we want to return metric data, we call get detailed weather by date metric on the future weather DAO. Otherwise, if we want to fetch imperial, we call the proper imperial function on future weather DAO. That's all there is to the repository because everything else is already implemented, which is really awesome. Now we can move on to the UI part of the app. So we want to open up UI package, then weather, future, and detail, and we want to modify the future detail weather view model. It's gonna be really similar to the future list weather view model. It gets a detailed date, a forecast repository passed into it, and also a unit provider. It is a subclass of weather view model, which was already created a few parts ago. And then it also has a weather lazy property, which is gotten by lazy deferred. And here we are simply calling forecast repository get future weather by date, which is the function that we have just created right now. And we pass in the detailed date and also whether or not we wanna fetch metric weather. Because we have created the view model, we also need to create the view model factory. It's gonna look like every other factory that we have yet created. This means that we pass in the detailed date, the forecast repository, and also the unit provider. We subclass new instance factory. And then we simply override the create function and return our beloved future detail weather view model from here and cast it as the generic type T. Now comes the time to bind this factory and this view model with the Kotlin library. But notice something here. We are passing in the detail date. That's not the case with the list view model. There we are passing only forecast repository and the unit provider. The same goes for the current weather view model. Over there we are also passing in only the repository and the unit provider. So we have an extra property to take care of, and that can be a little bit tricky because this detail date is not a constant thing. Sometimes we're going to pass in the 2nd of February, sometimes we're going to pass in the 1st of July. However, the forecast repository and unit provider are always going to be the same instances. That's not true for the detail date. So let's see how we can handle this detail date in our dependency injection framework. It turns out that with Kotlin it's not all that hard. we're going to bind our future detail weather view model factory from a factory. We can pass anything to a factory, so we can pass in even the detail date of type local date. And then from this factory inline function, we want to simply return future detail weather view model factory. And this factory takes in the detail date and then an instance of forecast repository and also the unit provider. So the final thing is going to look like this. We have detail date and then 2 instances. We're going to call this factory from the fragment itself. So over there we are going to get the current date and pass it over here. Before we get to the Kotlin code for the future detail weather fragment, we need to create its XML layout. It's gonna be pretty much the same as the current weather fragment layout, which looks like this. And the future detail weather fragment layout is going to look like this. Pretty similar. Also, you can, as always, get the code from the link in the video description. Alright now, so what do we want to do? Well, whenever we tap on an entry, for example, this one for the 3rd of February, we want to pass this date to the detail fragment so that we can then later pass this date over to our view model to fetch the data from the database. To demonstrate, we press here, data gets passed to the fragment, this fragment passes that over to the view model then later gets the data from the database. This all happens in the matter of nanoseconds probably, and we are presented with a nice UI. So how are we going to pass data between the list and the detail? The answer is safe arguments. So let's open up the navigation tab under res, then go to mobile navigation.xml, go to its design tab. Let's reorder this a bit. So we have future list weather fragment, and then right after that we have future detail weather fragment. And we want to drag an arrow from the list to the detail. We are going to call this arrow action detail. So over here, this ID is gonna be action detail. Once we have that, we want to click on the future detail weather fragment itself in the navigation here, and we want to add an argument to it. Its type is going to be string, and the name of it will be date string. So we have a single argument, and now when we take a look at this action arrow, you can see that this argument has appeared even inside here, but it's a little bit grayed out, so I hope that you can see it properly on YouTube as well. But we can always take a look at the text tab because everything is represented as an XML. So we have just added this action detail, right? This is the arrow, and then the fragment future detail weather fragment has a new argument, date string of type string. Alright, so before we get to the editing of the future detail weather fragment itself, we first want to go over to future list weather fragment, and all the way down where we are now displaying the toast, we want to delete this line which creates the toast, and instead we want to create a new function, show weather detail. This function will have 2 parameters, date and also view, and inside it we want to convert the date to a date string by using our local date converter, which is also used by the database itself. This is the class which we are talking about. It's the type converter for the database, but we can also use it outside of the database because why not? Once we have the date string, we are going to create an action detail by calling action detail on a class which is not yet present here. That's because we need to rebuild the project, which we are going to do in a short while. And then once we have the action detail, we are going to call navigation, find navigation controller on this view, and we are going to navigate by the action detail. So now let's even call this function. We are going to do it in a really Kotlin-esque way. So we are going to cast the item safely as future weather item, and basically if it is future weather item, we can then call let on it, also null safely, and then if everything works out, so if it is actually a future weather item, we want to show weather detail and pass in the item dot, or actually it because that's the implicit parameter of this let function. So it.weatherEntry.date. So we want to get it from the where entry, and also we want to pass in the view, which is the view of the list item itself. Alright, now all that we have to do is to go to build tab and rebuild the project, which is going to generate all of the classes for us. So even this future list weather fragment direction class. Alright, so as you can see, after the rebuild of the project, the class is present here. It's just a generated class by the navigation library. And also I have a separate tutorial on this navigation, so you can check it out by clicking on the card in the corner. Now we can finally start to implement the future detail weather fragment. As always, this fragment will inherit from scoped fragment. It's also going to implement Kotlin aware. We can delete this companion object, and instead we are going to have here override val Kotlin by closest Kotlin. And while in all of the other fragments we were creating or actually getting the view model factory by instance here, over in the future detail weather fragment, we need to do it a bit differently because we actually have a factory of a factory. So the name of this property is gonna be a bit funny. It's gonna be private val. And now listen closely. View model factory instance factory. So we have a factory of a factory. That's because we don't have the date yet, and we need to pass it to the factory, the Kotlin factory. So don't confuse those two factories. One is for creating view models, and another one is somehow a higher level factory. So that higher level Kotlin factory is for creating the view model factory. Alright, so this will be of type, basically a higher order function which gets a local date and passes that local date. So let's import that. Oh god, local date. I'm already used to the VS Code, so I am just pressing wrong key shortcuts all over the place. But anyway, we want to pass this local date over to the function, which is going to return future detail weather view model factory. And as we were getting the instances of those factories inside, for example, this list fragment by instance, the factory can be gotten by calling by factory. So let's import that. And let's reformat that a bit so that we can properly see it on the screen. Alright, now let's get to onActivity created, and here we need to pass in the view model factory to this view model providers of function. But in order to use that view model factory, we need to pass in the date to that factory. That date can be gotten from the save args, which we have just implemented a while ago. So we are going to create val save args, and it's going to be equal to arguments, which are just standard arguments which every single fragment in Android has. And if those arguments are not null, so null save access operator and then let, and then we wanna call future detail weather fragment args, which is another generated class from the navigation library, and we want to call from bundle, and the bundle is it, which is an implicit parameter of this let function. Once we have the safe arguments, we want to create the proper date. It's going to be equal to local date converter, which is our function again, which is used in the database, also the type converter. And on this date converter, we want to call string to date, and the string which we are going to pass there is present on save args, and its name is date string. And finally, if something goes wrong, so if this date string is just null and then this string to date returns null, so we want to use the null coalescing operator. And if something like that happens, so the left side of the null coalescing operator is null, we then want to throw an exception, and we are going to create that exception right now under our trusted package internal here. Then we have exceptions.kotlin file, and we want to create new exception, which is going to be called date not found exception. You can immediately see the benefit of having a proper naming scheme for our classes and packages and to have them nicely organized, because now whenever we want to find something, we can find it pretty easily. Once we have this exception, we can go over to future detail weather fragment and throw it over here. So how's it called? Date not found exception? Yep, so we want to throw it over here. Oh, not date time exception, but date not found exception. Now let's pass the aforementioned viewModel factory over to this auth function. So we want to pass in viewModel factory instance factory, whatever that factory of Kotlin returns. And to this instance factory, we want to pass in the date. Oh, and we cannot pass in the date because we have made a little mistake here, right here. So this local date, we are going to delete it because it's not from Java time, but it should rather be from the org13bp local date. And now this error is gone, so everything is working properly. And then we simply want to call bindUI function. And now we just want to implement this bindUI function and all of the functions which this bindUI will call. It's a really long list of functions because, yeah, we have a lot of stuff in the UI, so I'm not even going to go over this, but it's really similar to all of the other bindUI functions which we have created up until this point. And also, as always, you can get the code from the link in the video description, which is going to take you to resocoder.com. So we've got all these functions, but we need to import some things here. So for example, this observer, so import lifecycle observer, and also import glide app. And once we have that all imported and implemented, we are really just good to go. So let's open up the emulator. Let's close all of the other instances of the app which we have now open. And now comes the time to run the app. So let's hit the play button and build and run this app. And the app is running. So we are in the Today tab. That works properly, I hope. And then we can go to 7 days tab. It's going to open up the list of all items. We are using imperial weather data, so we have degrees Fahrenheit. And when we click, for example, on this February the 4th of 2019 already, wow, the time flies, it's already like 3 months since the start of this series, so thanks for sticking thus far. So let's click here, and it's going to open up the detail weather fragment, and the temperatures are matching. Yeah, that's right, 53.1 even over in the detail, but we have more data which was fetched from the database table. So we have even the minimum and maximum temperature. Then we have wind speed, precipitation in inches, visibility in miles, and UV in some UV index units. I don't know what they are, to be honest. And we also get the nice picture and also the state of the weather. Then when we go to settings and change the unit system to be metric, we go back to 7 days, we can see that it still works, so 11.7 degrees Celsius. Alright, and that's it for this tutorial, and also basically for this tutorial series, because you can regard this part as the last part in the MVVM forecast app course, because now the app is all properly implemented. We have the today weather, we have the 7 days forecast, we have also now just implemented the detail of the future weather. Then we have the settings. We can use device location, but when we are on emulator, it's going to just pick up some random location. So again, Santiago Villa Mobile Home Park, and so I don't know where that is, but I guess it's nice over there, I hope. Over the course of this tutorial series, you've learned how to build a proper MVVM app with all the proper structure and architecture, which really every single app should have when you are building Android apps. We are fetching data from a remote API, which is called AppPixu. Then you also learned how to store this data from that API and how to convert it from JSON to some Kotlin objects, and then those objects are entities which are then later converted to SQL data, which is stored in the SQLite database right on the device. Then we are fetching that data from that database through repositories, and we are passing it all over the place to the fragments, through the view models. So yeah, you've learned a lot from this tutorial series, I hope, and I'm sure that you've learned a lot, because it's not even possible to watch something like this and not come out enriched in some form as a software developer, as an app developer. So really, if this tutorial helped you, and if this tutorial series helped you to become a better app developer, Android developer, and overall just a better programmer because you've learned some new concepts and things, definitely give this video a like and also share it with others so that they can learn the same awesome stuff. Subscribe to this channel if you don't want to miss my future videos, and also hit the bell button so that you can join the notification squad and be notified about every single new video that I upload. Leave a comment if you have anything to say, any questions, suggestions, or really just anything. Follow me on Instagram, Facebook, and Twitter, and see you in the next video.